Now another application of self-adjusting property is to prove formulas along with their conditions. So here we'll be proving formulas and we'll start with the first one, and that is if x is greater than equal to 0 and y is greater than equal to 0, we'll need to prove that sin inverse x plus sin inverse y, it will be sin inverse x under root 1 minus y square plus y under root 1 minus x square if x square plus y square is less than equal to 1 and it'll be equal to pi minus sin inverse x into under root 1 minus y square plus y into under root 1 minus x square if x square plus y square is greater than 1. Now when I look at this x into under root 1 minus y square plus y into under root 1 minus x square, it reminds me of sin a cos b and cos a sin b. So what we'll do is we'll try and simplify this expression, which is sin inverse x under root 1 minus y square plus y under root 1 minus x square. Now what we'll do is we'll let x as sin a and y as sin b. So we can write this expression E as sin inverse sin a cos b plus cos a sin b, and that is nothing but sin a plus b. So we can write this as sin inverse sin a plus b. Now we can cancel sin inverse with sin if a plus b lies in the principal value range. So we'll have this first case when a plus b, it is less than or equal to pi by 2 but greater than or equal to 0. Since we have taken x and y, both of them as positive number, it cannot take a negative value. Now in this interval, this sin inverse and sin will cancel. So we'll get this E as sin inverse x plus sin inverse y, and we'll simplify this condition. So A is sin inverse of x and B is sin inverse of y. So we can write sin inverse of x plus sin inverse of y is less than equal to pi by 2. Now we'll take this sin inverse y on the right hand side. So we can write sin inverse of x is less than equal to pi by 2 minus sin inverse y, and pi by 2 minus sin inverse y is cos inverse y. So we can write sin inverse x is less than equal to cos inverse of y. Now we can take sin both sides. So we can write x is less than equal to sin cos inverse y. Now we have to change cos inverse y in terms of sin inverse. So what we'll do is we'll take cos inverse y is theta, that is cos theta is y. So we'll draw a right angle triangle. So this is theta, this is y, this is 1, and this is under root of 1 minus y square. So sin theta here will be under root of 1 minus y square. So we'll get x is less than equal to under root of 1 minus y square, or we'll get this condition which is x square plus y square is less than equal to 1. So when x square plus y square is less than equal to 1, then sin inverse x under root 1 minus y square plus y into under root 1 minus x square is equal to sin inverse x plus sin inverse y, and that is the first part of our result. When x square plus y square is less than equal to 1, then we can simply write sin inverse x plus sin inverse y as sin inverse x under root 1 minus y square plus y under root 1 minus x square. Now we'll consider the second case when a plus b is greater than pi by 2 but less than or equal to pi. Now if a plus b is greater than pi by 2, we'll get the similar condition, sin inverse x plus sin inverse y is greater than pi by 2. Now we'll simplify this. We'll get x square plus y square is greater than 1. So we are dealing with the condition when x square plus y square is greater than 1. Now when a plus b is greater than pi by 2, then if we draw the graph of sine inverse of sine x, in this interval from pi by 2 to pi, this definition is minus x plus pi. So we can write this e as pi minus and then x. X in this case is a plus b. So this e, it will be pi minus sine inverse x plus sine inverse y. So we can write sine inverse x under root 1 minus y square plus y under root 1 minus x square will be equal to pi minus sine inverse x plus sine inverse y. Now we interchange both of them, then we'll get the result for the second part, which is when x square plus y square is greater than 1, in that case, the value of sine inverse x plus sine inverse y, it will be pi minus sine inverse x under root 1 minus y square plus y under root 1 minus x square. So this is how we use self-adjusting property to prove formulas. Now we have proved the formula when x and y, they are both greater than 0. If x and y, they are negative number, then we'll simply use this property. Sine inverse of minus x is minus sine inverse of x, and then we can adjust the formula accordingly. Now, why are we getting two different results? We are getting two different results because the principal value range of sine inverse x when x is greater than or equal to 0 is from 0 to pi by 2, and for sine inverse y also it will be from 0 to pi by 2. Now, any sine inverse, its range, it will be from minus pi by 2 to plus pi by 2. So this sine inverse x under root 1 minus y square plus y under root 1 minus x square can take the maximum value of pi by 2. So this formula is valid when the sum of these two angles on the left, it is less than or equal to pi by 2. But when the angle, it is greater than pi by 2, it goes in the second quadrant, then in that case, it is no longer equal to sine inverse of this value, but it will be equal to pi minus sine inverse of x under root 1 minus y square plus y under root 1 minus x square. And we have used this formula using simple trigonometric formula. Sine a plus b is sine a cos b plus cos a sine b. In the same way, we can prove the formula for sine inverse x minus sine inverse y. And here also we have taken x and y, both of them as positive numbers. Now sine inverse x minus sine inverse y will be sine inverse x under root 1 minus y square minus y under root 1 minus x square, as the formula is sine a cos b minus cos a sine b. Now in this case, we do not have any other condition, because if x is greater than y, then the expression on the left hand side will be positive and the expression on the right hand side will also be positive. And if x is less than y, then both these expressions will be negative. So formula is going to adjust accordingly for any positive values of x and y. So here we have just one formula, and that is sine inverse x minus sine inverse y, and it is equal to sine inverse x under root 1 minus y square minus y into under root 1 minus x square. Now we'll prove the second set of formulae, and that is for cos inverse. Now again here we are taking x and y as positive numbers, and first we'll prove this formula, which is cos inverse x minus cos inverse y, and it'll be cos inverse xy plus under root of 1 minus x square into 1 minus y square if x is less than or equal to y, and it'll be minus cos inverse xy plus under root of 1 minus x square into under root of 1 minus y square when x is greater than y. Now clearly we know that we have to use the formula for cos a minus b. Cos a minus b is cos a cos b plus sin a sin b. So we'll start with this expression, say E, which is cos inverse xy plus under root of 1 minus x square into under root of 1 minus y square, and we let x as cos A and y as cos B. Now we'll put the value of x and y here. We'll get this E as cos inverse. Now it will be cos A cos B plus sin A sin B, and we'll get this as cos A minus B. So this E will be cos inverse of cos A minus B. Now we can cancel this cos inverse with cos only if A minus B lies in the principal value range. So we have this first condition when A minus B is greater than or equal to 0. So from here we'll get this condition that A is greater than or equal to B. Now A is cos inverse of x. So we'll get cos inverse of x is greater than or equal to cos inverse of y. Now cos inverse, it is a decreasing function. And because it is a decreasing function, so we'll cancel cos inverse, then sign of inequality will change. So we'll get this condition that x is less than or equal to y. Now when x is less than or equal to y, then this A minus B is greater than 0. Then it lies in principal value range of cos inverse. So here cos inverse and cos will cancel. We'll get this E as A minus B, and A is cos inverse x and B is cos inverse y. So we'll get this formula that cos inverse x minus cos inverse y, it will be equal to cos inverse xy plus under root 1 minus x square into under root 1 minus y square when x is less than or equal to y. And that is the first part of our formula. Now we'll consider the second case when A minus B is actually less than 0. That is when A is less than B, which simply translates to cos inverse x is less than cos inverse y. So from here we'll get the condition that x is greater than y. So if x is greater than y, in that case, this angle, it is no longer in principal value range. So we have to go back to the graph of cos inverse of cos x. So when x is less than 0, this definition is minus x. So when we cancel this cos inverse with cos x, it will be simply minus x. So it will be minus A plus B. So we'll get this result as minus, and then A is cos inverse x minus cos inverse of y. So from here we'll get our second condition, which is cos inverse x minus cos inverse y. It will be minus cos inverse xy under root 1 minus x square into under root 1 minus y square when x is greater than y. Now in the same way, for x greater than or equal to 0 and y greater than or equal to 0, we can prove the formula that cos inverse x plus cos inverse y, it will be cos inverse xy minus under root of 1 minus x square into under root of 1 minus y square. And for this formula also, when x and y, they are positive, there is no other restriction, because cos inverse x, it will lie between 0 to pi by 2. Cos inverse y will also lie between 0 to pi by 2, as x and y, they are both positive numbers. So this expression on the right hand side, it can take the value from 0 to pi. So there is no need for any additional condition for this formula. Now we'll come to our third set of formula, and here also we'll take x as greater than 0 and y is also greater than 0, and the formula is tan inverse x plus tan inverse y, and this formula is, this is tan inverse x plus y upon 1 minus xy if x into y is less than 1. It is pi by 2 when x into y is equal to 1, and it will be pi plus tan inverse x plus y upon 1 minus xy when xy is greater than 1. So again, we'll start with this expression, which is E, and that is tan inverse x plus y upon 1 minus xy. Now we'll let x as 10a and y as 10b. So we'll get this expression as E equals 10 inverse. Now this is 10a plus 10b upon 1 minus 10a 10b. So it will be simply 10a plus b. Now depending on the value of a plus b, we'll get different conditions. So we'll take this first condition when a plus b, it lies in principal value range, that is when a plus b is less than pi by 2. So if a plus b is less than pi by 2, in that case 10 inverse and 10 will cancel. So we'll get this E as a plus b. Now a is 10 inverse x and b is 10 inverse y. So we'll get this E as 10 inverse of x plus 10 inverse of y, provided a plus b is less than pi by 2. Now a is 10 inverse of x and b is 10 inverse of y and it is less than pi by 2. Now we'll take this 10 inverse y on the right hand side. So we'll get 10 inverse of x is less than, now pi by 2 minus 10 inverse y is cot inverse. So there'll be cot inverse y, and since x and y they are positive, cot inverse y is 10 inverse 1 upon y. So we'll get 10 inverse x is less than 10 inverse 1 upon y. So we'll cancel 10 inverse. We'll get this condition that xy is less than 1. So if xy is less than 1, in that case 10 inverse x plus 10 inverse y, and it'll be equal to 10 inverse x plus y upon 1 minus xy. Now for the second part, when a plus b is greater than pi by 2, which translates to xy greater than 1. If we look at the graph of 10 inverse of 10x, then in this interval between pi by 2 and pi, its definition is x minus pi. So we'll get this expression as a plus b minus pi. So this E in that case will be 10 inverse x plus 10 inverse y minus pi. Now we'll equate both of them. We'll take this pi on the left hand side. Then we can write 10 inverse x plus 10 inverse y. It will be pi plus 10 inverse x plus y upon 1 minus xy when xy is greater than 1. Now when x into y is equal to 1, we can write y is 1 upon x. Then in that case, it will be 10 inverse x plus 10 inverse 1 upon x, and 10 inverse 1 upon x is cot inverse of x. So we'll get 10 inverse x plus cot inverse x, and which is nothing but an identity, and it will be equal to pi by 2. So when x into y is equal to 1, then value of 10 inverse x plus 10 inverse y, it will be pi by 2. And the second part of the formula is, if x is greater than 0 and y is greater than 0, then simply 10 inverse x minus 10 inverse y, it will be 10 inverse x minus y upon 1 plus xy. And there is no other restriction to the formula till we have this condition that both the numbers are positive. And this formula is particularly very important in sequences and series. We'll be solving questions where we'll have series containing expressions of 10 inverse, where we'll be using this formula to use method of difference. Now here I'll mention just two more formulas, and the first one is 10 inverse x1 plus 10 inverse x2 plus 10 inverse xn, and it'll be 10 inverse S1 minus S3 plus S5 with alternate plus minus sign, and then 1 minus S2 plus S4 minus S6, where S1 is sum of values of x1, x2, x3, xn. S2 is sum of x1, x2, x3, xn taken two at a time. Sn is product of all these values. So from here we can write formula for 10 inverse x plus 10 inverse y plus 10 inverse z, and it'll be 10 inverse. Now what is S1? S1 is sum of all the values. So it'll be x plus y plus z minus S3. S3 is product of all three. and then 1 minus S2. S2 is taken 2 at a time, so it will be xy plus yz plus zx, and then there will be no S4. So that is the formula for tan inverse x plus tan inverse y plus tan inverse z, and it is tan inverse x plus y plus z minus xyz upon 1 minus xy minus yz minus zx. So we'll use this formula if we have 3 or more expressions. Now here the question is, if x1, x2, x3 and x4 are roots of the equation x to the power 4 minus x cube sine 2 beta plus x square cos 2 beta minus x cos beta minus sine beta equals 0, then we need to find the value of summation I varies from 1 to 4 tan inverse xi. Now we know that this sum, it is equal to tan inverse S1 minus S3 upon 1 minus S2 plus S4. Now it will be tan inverse. Now what is S1? S1 is sine 2 beta minus, now what's S3? S3 is cos beta. So it will be sine 2 beta minus cos beta 1 minus S2. S2 is cos 2 beta and then minus sine beta. Now we can write sine 2 beta as 2 sine beta cos beta. So it will be tan inverse, and we'll take cos beta common. So it will be 2 sine beta minus 1, and here 1 minus cos 2 beta will be 2 sine square beta, and here also we'll take sine beta common. So it will be 2 sine beta minus 1, which will cancel. So we'll get this as tan inverse into cot beta, and we can write cot beta as tan pi by 2 minus beta. Now tan inverse and tan will cancel. So this value, it is pi by 2 minus beta, and that's your option C. Now we'll take some questions on addition formulas of inverse trigonometric function. Now here the question is, if cos inverse x plus cos inverse y by 2 equals alpha, then for all xy, this 4x square minus 4xy cos alpha plus y square is equal to which of the following expression? Now we'll use the formula for cos inverse x minus cos inverse y. Now the formula is cos inverse xy, so it will be xy by 2 and plus under root of 1 minus x square into under root of 1 minus y square, and y in this case is y by 2. So it will be y square by 4 and it should be alpha. Now we'll take this cos on the right hand side. We can write xy upon 2 plus under root of 1 minus x square minus y square by 4 plus x square y square by 4 equals cos alpha. Now we'll take this xy by 2 on the right hand side and we'll square. So we'll square, we get 1 minus x square minus y square by 4 plus x square y square by 4, and it'll be equal to cos square alpha plus x square y square by 4 and minus xy cos alpha. Now x square y square by 4 will cancel. We'll take this cos square alpha on the left hand side. So we'll get 1 minus cos square alpha, and it'll be x square plus y square by 4 minus xy cos alpha. Now 1 minus cos square alpha is sin square alpha, and we'll multiply everything with 4. We'll get 4 sin square alpha, and it'll be equal to 4x square plus y square minus 4xy cos alpha, and that's your option C. Now here the question is, we need to find the value of sin inverse 12 by 13 minus sin inverse 3 by 5. Now we know that sin inverse x minus sin inverse y is sin inverse x under root 1 minus y square minus y under root 1 minus x square. So we can write this as sin inverse 12 by 13 into under root of 1 minus 9 by 25 minus 3 by 5 into under root of 1 minus 144 divided by 169. So we can write this as sin inverse 12 by 13 into 4 by 5 minus 3 by 5 into 5 by 13. So it'll be sine inverse, and there'll be 48 minus 15 upon 65. So we can write this as sine inverse 33 by 65. Now there is no option which matches with it. So what we'll do is we'll try and change it in cos inverse. So we can write this as cos inverse under root of 1 minus 33 upon 65 whole square. So it'll be cos inverse of under root of, now this is 65 plus 33 and 65 minus 33 upon 65 square. So it'll be cos inverse of 56 65, and we can write cos inverse as pi by 2 minus sine inverse of 56 upon 65, and that's your option B. Now here the question is, if alpha is cos inverse of 3 by 5 and beta is tan inverse of 1 by 3, then we'll need to find the value of alpha minus beta. Now what we'll do is we'll change this cos inverse in terms of tan inverse. So here cos alpha is 3 by 5. So we'll draw a right angle triangle. So this is 3, 5 and 4. So we can write alpha as tan inverse 4 by 3. Now we need to find the value of alpha minus beta, which is tan inverse 4 by 3 minus tan inverse 1 by 3. Now we can write this as tan inverse x minus y, which is 4 by 3 minus 1 by 3 upon 1 plus 4 by 9. So it will be tan inverse. Now it will be 9 by 13. Now there is no option in tan inverse which matches with it. So we'll try and change it in terms of sine and cos. So this is, let some angle theta. So this is 9. It is 13. And here it will be under root of 13 square plus 9 square. And it is 5 under root 10. So we can write this as sine inverse 9 upon 5 root 10, and it will also be equal to cos inverse 13 upon 5 root 10, and option D, it matches with it. So answer to this question is option D. Now it says, considering only the principal values of tan inverse function when x is greater than or equal to 0, we need to find solution to this equation, which is tan inverse of 2x plus tan inverse of 3x, and it is equal to pi by 4. Now we know that formula for tan inverse x plus tan inverse y depends on the product xy. So we'll consider this first case when product of xy, which in this case is 2x into 3x, it is less than 1. That is when the value of x is less than 1 by under root 6. Then in that case we can write this as tan inverse x plus y. So it will be 5x upon 1 minus 6x square, and it will be equal to pi by 4. So we'll write this as 5x upon 1 minus 6x square equals 10 pi by 4, which is 1. So we'll write this as 6x square plus 5x minus 1 equals 0. So it'll be 6x square plus 6x minus x minus 1. So it'll be 6x minus 1 into x plus 1 equals 0. So value of x is either 1 by 6 or value of x is minus 1. Now in the question it says x is greater than 0. So we cannot take x as minus 1. So the only solution that we'll get from this case is x equals 1 by 6. So the only solution that we get from here is x equals 1 by 6. Now for the remaining two cases, xy equals 1 and xy greater than 1, there also we won't get any solution. So there is only one solution to this question. So answer to this question is this set A is a singleton, and that's your option B. Now here the question is, if x, y, z are in AP and tan inverse x plus tan inverse y plus tan inverse z, they are also in AP, then which of the following option is correct? So if they are in AP, then we know that y minus x equals z minus y, and it'll be equal to common difference D, and we can also write tan inverse y minus tan inverse x, it must be equal to tan inverse z minus tan inverse of y. Now we'll use the formula, so it'll be tan inverse y minus x upon 1 plus xy, and it should be equals to tan inverse z minus y upon 1 plus zy. Now we can cancel tan inverse. Now y minus x is D, and z minus y is also d. So we'll get d upon 1 plus xy, and it is equal to d upon 1 plus zy. So from here we'll get this condition, either d is 0 or 1 plus xy is equal to 1 plus zy. Now if d is 0, then basically x equals y equals z. And if we'll take this other condition, here 1 will cancel. Here we'll get x minus z into y equals 0. So either x equals z or y equals 0. If x is equal to z, then from here also we'll get the same condition, that x is equal to y and it is equal to z. So the answer to this question is this option A, x equals y equals z. Now here the question is cot inverse under root cos alpha minus tan inverse under root cos alpha equals x. Then we'll need to find the value of sin x. Now what we'll do is we'll write this x as tan inverse of 1 upon under root cos alpha minus tan inverse of under root cos alpha. Now we'll use the formula for tan inverse x minus y. So it'll be tan inverse 1 upon under root cos alpha minus under root cos alpha upon 1 plus 1 upon under root cos alpha into under root cos alpha. Now we'll cancel. So we'll get this x as tan inverse 1 minus cos alpha upon 2 under root cos alpha. Now we'll take this tan inverse on the left hand side. We can write tan x as 1 minus cos alpha upon 2 under root cos alpha. Now we'll need to find the value of sin x. So we'll draw a right angle triangle. So this is your x. It is 1 minus cos alpha and this is 2 under root cos alpha. Now we'll find its hypotenuse. So this hypotenuse will be under root of 1 minus cos alpha whole square plus 4 cos alpha, and it'll be 1 plus cos alpha. So from here we can write sin x as 1 minus cos alpha upon 1 plus cos alpha. Now 1 minus cos alpha is 2 sin square alpha by 2, and 1 plus cos alpha is 2 cos square alpha by 2. Here 2 will cancel. So now we can write this sin x as tan square alpha by 2, and that's your option 1. Now here the question is, we need to show that cos inverse root 2 by 3 minus cos inverse under root 6 plus 1 upon 2 root 3, and this value is pi by 6. Now what we'll do is we'll write this as cos inverse root 2 by 3 and then minus cos inverse, and then we can write this as under root 6 upon 2 root 3 plus 1 upon 2 root 3, which we can also write as cos inverse root 2 by 3 minus cos inverse, and here we can rewrite this as root 3 by 2 into root 2 by 3 and then plus 1 by 2 into under root of 1 minus root 2 by 3 whole square. Now this is cos A cos B plus sin A sin B. Now this is cos inverse xy plus under root of 1 minus x square into under root of 1 minus y square, which is nothing but, which is cos inverse x minus cos inverse y, where x is less than y. So it will be cos inverse under root 2 by 3 minus cos inverse root 3 by 2. Now here cos inverse root 2 by 3 will cancel. So we'll get this result as cos inverse root 3 by 2, and which is nothing but pi by 6. And that is the answer to this question. Now here the question is, if tan inverse y equals tan inverse x plus tan inverse 2x upon 1 minus x square, where mod x is less than 1 by root 3, then the value of y is. Now what we can do is we can write this as tan inverse y equals tan inverse x plus tan inverse 2x upon 1 minus x square when x lies between minus 1 by root 3 and plus 1 by root 3. Now we'll put x as tan theta. So we can write tan inverse y as tan inverse of tan theta, and it'll be tan inverse of tan 2 theta. Now here if we'll put x as 10 theta, then theta will lie between minus pi by 6 and plus pi by 6. Now this theta, it lies in principal value range. So it will be simply theta, and 2 theta, it will also lie in principal value range. So it will be simply 2 theta. So we can write this y as 10 3 theta. Now 10 3 theta is 3 10 theta minus 10 cube theta upon 1 minus 3 10 square theta. So it will be 3x minus x cube upon 1 minus 3x square, and that's your option A. Now here the question is, if cos inverse under root p plus cos inverse under root of 1 minus p plus cos inverse under root of 1 minus q equals 3 pi by 4, then the value of q is. Now if we look at this cos inverse under root p and cos inverse under root of 1 minus p, we can write cos inverse of under root 1 minus p as cos inverse under root p plus cos inverse 1 minus under root of p square. Now we know that cos inverse of under root of 1 minus x square is nothing but sine inverse. So actually it will be cos inverse under root p plus sine inverse under root of p, and which is nothing but identity in inverse trigonometric function. So it is nothing but pi by 2. So we can replace first two terms with pi by 2. So it will be pi by 2 plus cos inverse under root of 1 minus q. It is 3 pi by 4. So cos inverse 1 minus q will be simply pi by 4, and under root of 1 minus q will be cos pi by 4, and it is 1 by root 2. So value of q is simply 1 by 2, and that's your option D. So value of q should be 1 by 2. Now here the question is, if a, b, c are positive real numbers and theta is tan inverse under root a into a plus b plus c upon bc plus tan inverse b into a plus b plus c upon ca plus tan inverse c a plus b plus c upon ab, then tan theta is equal to which of the following? Now what we'll do is, we'll write a plus b plus c as some value and say d. So we can write this as theta equals tan inverse under root of AD upon BC plus tan inverse of under root of BD upon CA plus tan inverse of under root CD upon AB. Now we'll use the formula for tan inverse x plus tan inverse y. Now we look at product of x, y, it will be under root of AD upon BC into under root of BD upon CA. Now here A will cancel, B will also cancel. We'll get this as D upon C, and D upon C is greater than 1. And when product of xy is greater than 1, we'll write this as pi plus tan inverse x plus y. So it will be under root of AD upon BC plus under root of BD upon CA upon 1 minus AD upon BC into BD upon CA plus tan inverse under root CD upon AB. So it will be pi plus tan inverse. Now here we'll take under root D upon C common, then we'll get A plus B upon under root AB, and here we'll get 1 minus D upon C and plus tan inverse under root CD upon AB. So we can write this as pi plus tan inverse. Now it will be under root D upon C, and it is A plus B upon under root AB. Now D is A plus B plus C. So here we'll get minus A plus B upon C plus tan inverse under root CD by AB. Now here A plus B will cancel. Now this under root C will also cancel. So we'll get this under root C in the numerator. Now we can write this as pi plus tan inverse and then minus under root CD upon AB plus tan inverse under root CD upon AB. Now this tan inverse under root CD upon AB will cancel. So answer to this question will be simply pi. Now here the question is, find the simplest value of cos inverse of x plus cos inverse of x by 2 plus 1 by 2 under root of 3 minus 3x square, where x belongs to 1 by 2 to 1. Now here what we'll do is, we'll let x as cos theta, and if cos theta lies between 1 by 2 and 1, then theta lies between 0 and pi by 3. Now we can write this as y equals cos inverse of cos theta plus cos inverse of 1 by 2 cos theta plus root 3 by 2 sin theta. Now since theta lies in principal value range, cos inverse of cos theta is simply theta, and this is cos inverse, and this is cos A cos B plus sin A sin B. So we can write this as cos pi by 3 minus theta. Now we'll take minus here, we'll get 0 is greater than minus theta is greater than minus pi by 3. Now we'll add pi by 3, so it'll be pi by 3 is greater than pi by 3 minus theta is greater than 0. So this pi by 3 minus theta, it lies in principal value range of cos inverse. So again cos inverse and cos will cancel. So we'll get this y as theta plus pi by 3 minus theta. Theta and theta will cancel. So value of y will be pi by 3. So the simplest value of this expression when x lies between 1 by 2 and 1 is pi by 3. Now here the question is, find all the positive integral solutions of tan inverse x plus cos inverse y under root 1 plus y square equals sin inverse 3 by root 10. Now we'll change everything in terms of 10. Say this is theta. So we'll get cos theta as y upon under root 1 plus y square. So if this is theta, this is y, this is under root 1 plus y square, so it'll be 1. So we'll get this as tan inverse x, and we can write theta as tan inverse of 1 by y. And it'll be equal to, now say this is alpha, so sin alpha is 3 by under root 10. So this is alpha, this is 3, this is under root 10, and this is 1, and it'll be equal to tan inverse of 3. Now we'll use the formula for tan inverse x plus tan inverse y. Then we'll get tan inverse x plus 1 upon y upon 1 minus x upon y. And this value will be equal to tan inverse 3. Now we'll cancel tan inverse with tan inverse. We'll get xy plus 1 y minus x, and it is equal to 3. We can write this as xy plus 1 equals 3y minus 3x. So here the value of x will be 3y minus 1 upon y plus 3. Now what we'll do is, we'll add 9 and subtract 9. So we can write this as 3 minus 10 upon y plus 3. Now since x is an integer, that means this right hand side, it must also be an integer, and it'll be integer when this y plus 3 divides 10. Now y plus 3 will divide 10 for positive value of y when the value of y is either 2 or when the value of y is either 7. Now we'll take y as 2, we'll get x as 1, and if we'll take y as 7, we'll get x as 2. So there are two solutions possible in this case. First case, when the value of x is 1 and y is 2, and second case, when the value of x is 2 and value of y is 7. We'll need to simplify tan inverse 3 sin 2 alpha upon 5 plus 3 cos 2 alpha plus tan inverse 10 alpha by 4, where alpha lies between minus pi by 2 and plus pi by 2. Now what we'll do is, we'll simplify this expression, and we'll write this as tan inverse, and this is 3, and we can write sin 2 alpha as 2 tan alpha upon 1 plus 10 square alpha, and in the same way we can write cos 2 alpha as 1 minus 10 square alpha upon 1 plus 10 square alpha, and then it'll be tan inverse 10 alpha by 4. Now we'll simplify this. We can write this as 10 inverse 6 10 alpha, and then it'll be 8 plus 2 10 square alpha plus 10 inverse 10 alpha by 4. Now here we'll cancel 2 in the numerator and denominator, and we can write this as 10 inverse 3 10 alpha upon 4 plus 10 square alpha and plus 10 inverse 10 alpha by 4. Now here we'll use the formula for 10 inverse x plus 10 inverse y. So it'll be 10 inverse 3 10 alpha upon 4 plus 10 square alpha plus 10 alpha by 4 upon 1 minus 3 10 square alpha and 16 plus 4 10 square alpha. So we can write this as 10 inverse. Now here it will be 12 10 alpha plus 4 10 alpha plus 10 cube alpha upon 16 plus 10 square alpha. Now here we'll take 10 alpha common. Then we can write this as 10 inverse 10 alpha, and it'll be 10 square alpha plus 16 upon 10 square alpha plus 16. Now 10 square alpha plus 16 will cancel. We'll get this as 10 inverse of 10 alpha, and which is equal to alpha, since in the question it says alpha lies in principal value range of 10 inverse. So answer to this question is simply alpha. The next question is, let cos inverse x plus cos inverse 2x plus cos inverse 3x be pi. Then if x satisfies this cubic equation, then find the value of b minus a minus c. Now we are given that cos inverse under root x plus cos inverse 2x plus cos inverse 3x, and it is equal to pi. Now what we'll do is we'll use the formula for cos inverse x plus cos inverse y. So it'll be cos inverse, and it'll be 2x square minus under root of 1 minus x square into under root of 1 minus 4x square, and here on the right hand side we'll write pi minus cos inverse 3x, and which is nothing but cos inverse minus 3x. Now we'll cancel this cos inverse, then we can write 2x square plus 3x will be equal to under root of 1 minus 5x square plus 4x to the power 4. Now we'll square both sides. We'll get 4x to the power 4 plus 9x square plus 12x cube, and it'll be 1 minus 5x square plus 4x to the power 4. Now 4x to the power 4 will cancel. So we can write this as 12x cube. Now 9x square plus 5x square. So it'll be 14x square minus 1 equals 0. Now we'll compare it with this given equation. Then the value of a is 12, value of b is 14, and value of c is 0. Now we need to find the value of b minus a minus c. Now b is 14, a is 12, and c is 0. So answer to this question is simply 2. Now here the question is, if theta equals tan inverse 2 tan square theta minus tan inverse 1 by 3 tan theta, then we'll need to find the value of tan theta. Now we'll use the formula for tan inverse x minus tan inverse y. We'll write theta equals tan inverse. Now it'll be 2 tan square theta minus 1 by 3 tan theta upon 1 plus 2 tan square theta into 1 by 3 tan theta. Now we'll take this tan inverse on the left hand side. So it'll be tan theta. So we can actually write this as tan theta into 1 plus 2 by 3 tan cube theta, and it'll be equal to 2 tan square theta minus 1 by 3 tan theta. Now what we can do is we can cancel this tan theta. So one of the solution that we'll get is value of tan theta is 0, which is not given in the options. Now we can write this as 2 tan cube theta plus 3 and it'll be equal to 6 tan theta minus 1. So we can write this equation as 2 tan cube theta minus 6 tan theta and plus 4 equals 0, which is tan cube theta minus 3 tan theta plus 2 equals 0. Now it's a cubic equation. We need to find roots of this cubic equation, which is x cube minus 3x plus 2 equals 0. One of the solution is x equals 1. Now we'll use synthetic division. So this is 1 and this is 1, 0, minus 3, 2. This is 1. Now 1, minus 2, 0. So we can factorize this as x minus 1 into x square plus x minus 2 equals 0. So it will be x minus 1 and then we can write this as x plus 2 into x minus 1 equals 0. So we'll get the values of x as 1, 1 and minus 2. So value of tan theta should be either 1 or minus 2, and which is your option A and B. Now here the question is, if tan inverse of A upon x plus tan inverse of B upon x plus tan inverse of C upon x plus tan inverse of D upon x is equal to pi by 2, then we'll need to find the value of this expression, which is x to the power 4 minus x square summation AB plus ABCD. Now we'll use the formula for tan inverse x plus y. We can write this as tan inverse A upon x plus B upon x 1 minus AB upon x square, and in the same way we can write this as C upon x plus D upon x 1 minus CD upon x square, and it is equal to pi by 2. So we'll get tan inverse. Now it'll be A plus BX upon x square minus AB, and we'll take this expression on the right hand side. We'll write this as pi by 2 minus tan inverse C plus DX upon x square minus CD. Now pi by 2 minus tan inverse x is cot inverse. So we can write this as cot inverse C plus DX upon x square minus CD. Now cot inverse x is 1 upon tan inverse. So we can also write this as tan inverse x square minus CD upon C plus DX. Now here we'll cancel tan inverse with tan, and then if we'll cross multiply, we'll get A plus B into C plus D x square, and it'll be equal to x to the power 4 minus CD x square minus AB x square plus AB CD. So we can write this equation as x to the power 4 minus summation AB x square plus ABCD, and it is equal to 0. So value of this expression x to the power 4 plus x square summation AB plus ABCD is 0, and that's your option B. And it says if sin inverse AX plus cos inverse Y plus cos inverse BXY equals pi by 2, then for different values of A and B, which are the following options matches. So we'll take the sin inverse AX on the right. We can write cos inverse Y plus cos inverse BXY, and it'll be pi by 2 minus sin inverse AX. Now we'll use the formula for cos inverse X plus cos inverse Y. We can write this as cos inverse BXY square into under root of 1 minus Y square into 1 minus B square X square Y square, and it'll be equal to pi by 2 minus sin inverse AX, which is nothing but cos inverse of AX. Now cos inverse will cancel. Now we'll take this AX on the left hand side, and we'll take this under root expression on the right, and we'll square. So we'll get BXY square minus AX whole square, and it'll be equal to 1 minus Y square minus B square X square Y square plus B square X square Y to the power 4. Now we'll square it. We'll get B square X square Y to the power 4 plus A square X square minus 2ab x square y square, and it'll be 1 minus y square minus b square x square y square plus b square x square y to the power 4. It'll cancel. So we can write this expression as a square x square plus y square plus b square minus 2ab x square y square, and it is equal to 1. Now we'll start putting in different values of a and b. So for this a, we'll put a as 1 and b as 0. So we'll put a as 1 and b as 0. We'll get x square plus y square, it is equal to 1. So in that case, this point, it will lie on a circle. So this a, it will match with b. Now we'll take a as 1 and b as 1. We'll get this as x square plus y square minus x square y square minus 1 equals 0. So we can write this as x square into 1 minus y square and then minus 1. 1 minus y square equals 0. So we can simply write this as 1 minus x square into 1 minus y square equals 0. So in that case, this point, it will lie on x square minus 1 into y square minus 1 equals 0. So this b, it matches with q. Now we'll take this third case when the value of a is 1 and when the value of b is 2. So we'll put a as 1 and b as 2. We'll get x square plus y square plus 4 minus 4 x square y square equals 1. So again we'll get this circle which is x square plus y square equals 1. So this c, it again matches with p. And finally, for d, we'll take a as 2 and b as 2. Then we'll get 4x square plus y square, and here will be 4 minus 8 minus 4 x square y square minus 1 equals 0. So we'll take 4x square common. So it will be 4x square into 1 minus y square and then minus 1. 1 minus y square equals 0. So we'll get 4x square minus 1 into 1 minus y square equals 0. And that's your option S. So this D, it matches with S. So answer to this question is PQPS.